Hello everyone, welcome back to a brand new episode of Iran Tech. I'm your host Ali Reza, and today we're going to be talking about lasers. We're going to go over the different usages of lasers in all sorts of different industries and see what the fuss is about, because lasers have a lot more usages than just being used as a precision tool. But we're also going to zero in on one particular use of lasers in the medical field. So without any further ado, let's get started. Lasers have their uses in all sorts of different industrial and medical fields. In industries, they can be used in a variety of precision tools and instrumentations. In the field of medicine, their usage varies a lot. For example, they can help in treating kidney stones using lithotripsy operations. And what that is essentially sending out a beam with a certain wavelength that is going to be absorbed by the large kidney stone to break it into smaller ones that are then going to be passed through the urinary system. And all sorts of different dentistry procedures. They can help the surgeon with precision cuts and all sorts of different usages. And all of that is possible through changing the wavelength, the pulse duration, and the wattage. In this episode, though, we're going to focus on one particular usage of lasers, and that is going to be in the hair removal procedures. So once we beam the laser onto the skin, we are working with different layers of the skin. So we have the epidermis layer on top. We don't really have much to do with this one. Then we have the dermis up until the hair follicles, and then the subcutis, which has the fat glands and the veins that feed into the hair follicle. This is the hair follicle. So when we're talking about the different wavelengths that this laser gun projects onto the skin, we have three wavelengths that this laser projects. We have the first one, which is called Alex wavelength. It is a 755 nanometer wavelength. And the second one, which is called the diode wavelength, which is a 805 nanometer. They mostly deal with the hair stem and the hair follicles. So when those beams are projected, the melanin inside of the hair shaft, which causes the hair to be black, absorbs the laser beam and it turns it into heat, which in turn damages the hair shaft as well as the hair follicle. This is where the hair grows inside of. So it is going to be damaged, and once you do this enough times, it is going to be damaged enough that the growth pace of the hair is going to be significantly reduced. It's never going to fully stop, but it's going to be reduced enough times that you don't really have to worry about it. There's still going to be cycles that you would need to go back to the clinic to do this procedure again, but at that point, the hair follicle is very much damaged and you don't really need to worry about the hair growing back. And then the third wavelength, which is the ND-YAG, is going to target the subcutis layer, which houses the food for the hair follicle, which includes the fat glands and whatever nutrients that the hair follicle needs to grow the hair. So the ND-YAG wavelength is going to target this part and basically cut off the supply, or at least damage the supply of nutrients to the hair follicle. That's the science behind how this laser works. And now we're going to have to take a closer look at this laser gun and the machine behind it. All right, now that we know how lasers can burn hair follicles and prevent them from growing back, let's talk about how they work using this laser hair removal machine. But first, I'm going to have to address the noise that is in this room. That is because of the cooling system being at work. Let's take a look at the cooling system, actually. So we have one very standard double fan intake and double exhaust. So this intakes the air with room temperature and lets out the hot air. And over here, we have 24 to 48 TECs, and that is a thermoelectric cooler. And that is used to cool down the water that is being pumped into our handpiece, which would be this, let's call it laser gun. So the water, the cool, almost 0 degrees Celsius water, is being pumped into this laser gun because of the immense amount of heat that it produces with every shot. And over here we have an extra couple of TECs, that is a thermoelectric cooler also, and I'm going to have to scrape off the ice so that you can see the lasers. This is armed and dangerous, so if I press the button, I'm going to fry something, so I will hold it like this. Anyways, yeah, we've got the TECs cooling down this aluminum alloy around the laser beams, which we're going to talk about the laser beams in just a little bit. But for now, let's focus our attention on how the device actually works, the software, the user interface, and how the user would actually use this on a patient. So let me take it out of standby. We've got a couple of options to start with. We've got the body size of the patient, and that is going to determine the area that we're going to be using this laser gun to roll around, and also the skin tone of the patient. So Iranians would sit around like number 3 and number 4. And also, we've got another thing, which is the area in the body that we're going to be using this laser gun on. So what they're going to do is, for example, the skin tone, when you determine that, it's going to determine the total amount of energy that you're going to be using on a given area of the skin. So the darker the skin tone, the more kilojoules you will need on a per area basis. And you can see here, let's take a look at some examples. So let's say I picked, let's say, the back that I'm going to use this machine on. So it gives me 29.7 kilojoules in total, and that is across 660 square centimeters. But if I go back and use it on a more sensitive area of the body, for example, the neck, the number goes down significantly to 7.4 kilojoules in 165 square centimeters. So the area is definitely smaller, and also the pressure, the amount of joules that we put on a per centimeter square basis is also a lot lower, because the skin in the neck is a lot more sensitive than the skin on the back, or for example, the skin on the foot. So that's all the parameters that we need to talk about for now. But now we're going to talk more about this laser on a more advanced version of their machine, and to talk about the different laser beams and the different wavelengths that we're going to be using. So, but before we go and talk about that, we need to take care of safety. So make sure you wear your safety goggles, whether you're using it as the operator or the patient on the bed. So these are the more advanced models, and before I show you why these are more advanced, because we have a transparent glass on this device, let me show you how the cooling works from more up close. We have a water tank right there, which has the cool water being pumped into the pump, which then runs through a filter and then comes into the handpiece right here. And then once it heats up into the handpiece, it is circulated back into the system. So these red lights show the heat, show the warm water. So it comes down to the radiator, it cools down a bit, it then goes into the TEC chiller, the thermoelectric cooler, that brings the temperature further down, and then it goes back into the tank and is run back by the pump through the filters, and then it comes back into the handpiece. Now, speaking of the handpiece, one of the reasons why this device is more advanced is because that instead of having to work with the display right here, the operator can just do certain settings on the display that is on the handpiece. But in terms of how this helps the operators, there's somebody else that can explain that better.
On the display at the back of the handpiece, you can adjust all the parameters that you can adjust on the main display. Why is this helpful? What it does is that it can cut down on the amount of time it takes for the operator to adjust the setting on the fly. Instead of having to go back to the main display every time the operator wants to change the parameter, they can adjust all of it, including frequency in hertz, amount of energy in joules, and the state of ice cooling right on the handpiece.
Now, to further explain why this device is more powerful, I'm going to have to pull out my calculator. So we're going to do some numbers. Let's say we are dealing with a 500 watts device and we want to get 10 joules out of it. So we got 10 joules divided by 500. That is 20 milliseconds. So this gives us the 10 joules in 20 milliseconds. But let's say I'm using this device, which is 1600 watts. So it is the same 10 joules divided by 1600. Now we are dealing with 6/1000th of a second. That is 0.6 milliseconds. So when you drop down the period of time that when you're shooting a laser, this makes the laser hurt a lot less. So we want maximum efficiency in the shortest amount of time, which a 1600 watt device can actually give us. Another reason why this device is more powerful is that it has more laser bars inside of our laser gun. Now I need to scrape off the ice a little bit. If you take a look inside this laser gun, you will see that the two that are brightest, those are the Alex wavelengths, and the other ones, which are a little bit dimmer, those are the diode wavelengths, and the ones that you actually cannot see are the invisible ND-YAG wavelengths. So more bars equals more power output. It takes less time to run through the whole procedure, means a better, more advanced device. Now let's go and take a look at the behind the scenes to see what made the production of this device possible with one of the people behind this project. I am joined now by CEO Sadra Sepehri, and the first thing that I want him to explain to me is the different fields and the different parts that went into making this machine and how they all integrated together.
منم سلام عرض میکنم خدمت شما. دستگاه ما در 3 حوزه مختلف مکانیک، الکتروتکنیک و نرم افزار و برنامه طراحی شده و طراحیش بر عهده نخبگان و متخصصین شرکت خودمون بوده. 0 تا 100 بحث مکانیک در گروه کارخانجات، 0 تا 100 بحث برنامه نویسی و الکترونیک در آزمایشگاه‌های مختص این شرکت انجام شد.
All right. Now let's get to the nitty-gritty details about the water cooling system. What makes this water cooling system? Well, first of all, it's multifaceted. What are the different parts that go into the water cooling system and what makes it unique?
یکی از تمرکزهای عمده ما روی سیستم گردش آب و خنک کنندگی چندگانه دستگاه‌هامون بوده و این مزیت رو به ما داده نسبت به سایر دستگاه‌ها که ما سیستم خنک کنندگی رو داخلی با حداقل تلفات و حد اکثر بازدهی در دستگاه بتونیم قرار بدیم.
Now, can you tell me what kind of standards that the device has gotten and is it ready to be exported as well?
به استانداردهایی با توجه به اینکه این تجهیز پزشکی و با سلامت جامعه مستقیما در ارتباط هست، استانداردهایی رو وزارت بهداشت، درمان، آموزش پزشکی و همچنین وزارت صنعت، معدن و تجارت به ما اجبار کردن برای اخذ اون. شامل استانداردهای ایمنی، EMC عمومی، سازگاری الکترومغناطیسی، عرضم به حضور شما استاندارد ایزو 13485 حساسیت سمیت سلولی و همچنین آزمون بالینی که مجموع مدت زمانی که این دستگاه تحت آزمون آزمایشگاه‌های همکار وزارت بهداشت، درمان و همچنین مرکز تحقیقات پوست و مو به عنوان آزمون بالینی بوده بیش از 1 سال زمان برده و پس از 1 سال دستگاه ما موفق شده که تمام آزمون‌ها رو با موفقیت بگذرونه و در نهایت منجر به اجازه عرضه و توزیع به بازار بشه.
All right, thank you very much, Sadra. On to some closing thoughts. The production capacity of this company is around 500 devices per year, and that is enough to fulfill the needs of the entire country. And also, it's going to save us a whole lot of $1 million because it costs 1/10 of the American model that is sometimes imported in the country. So the other thing that this device is good for is that it can turn into a catalyst for the entire medical industry in the country to start using lasers, to start incorporating lasers more into the medical procedures. For example, the ones that I mentioned at the top of the program, for example, treating diabetic ulcers, treating prostate cancer, the lithotripsy that I mentioned, and a whole lot of other usages, for example, pain relief. All right, that's going to do it for another edition of Iran Tech. Thank you guys very much for watching. I'll see you all next week, same time, right here.